Hello, welcome to everyone in this video. This is our lecture number 1 for quantum mechanics theoretical part. In this video, I want to discuss about some basic of quantum mechanics, black body radiation, Planck quantum hypothesis, Planck constant, and de-Broglie hypothesis. This will be covered in this lectures, right? So, if you want to watch the problem solution of quantum mechanics and the other part of physics related and some mathematics, you can go through the description box. There are separate playlists are given in the description box, or you can go to the YouTube channel physics by Laxmikanta sir. You will be get different physics related video with some basic problem solution, right? So let's start today's discussion. What about the quantum mechanics? You can see this is the syllabus for BSc honors of Calcutta University, that is says about the radiation, black body radiation, Planck quantum hypothesis, Planck constant. Derivation of Planck formula is not required. Photoelectric effect, Compton scattering, and Davison-German experiment, de-Broglie wavelength, wave particle duality, and the probability interpretation, double slit experiment of photon and electron, and position momentum, gamma ray microscopy through experiment, like that. And the basic quantum mechanics will be discussed in the lecture series. So this will be discussed in the lecture series. You can uh, go you can attach to it this channel so that you can cover up this one. So let's start today's discussion. First we can say that is the just understand what is the quantum mechanics. Just understand about the quantum mechanics. Understand of quantum mechanics. Just understand the quantum mechanics. If you consider the ceiling fan, just if you consider the ceiling fan, these fans have, when switched off, condition 1, switched off. If you consider as a this fan has a switched off, then what you can say? That is, you can you can say the position of blades accurately, right? So the position of blade can be set accurately when switched off then the velocity will be 0. When the velocity is 0 of this or tends to 0, you can say 0 or tends to 0. You can say that is that you can say about the particular position of these blades accurately. But when the switched on, that is velocity not equal to 0, then you cannot say about actual position of blades, right? So that's the difference, basic difference, you can say. That is, in this situation you can say the actual position of the blade, that is the when v is tends to 0. But when v is not equal to 0, you cannot say about the actual position of blade, but you can say, you can say the region of position. That's mean region of position. That's mean you can say that is the, in this region, that is the periphery of this. In this region these blades must be situated, right? So this is the basic difference. In that case you can say the actual position of the blade. This is the classical mechanics, you can say about this is as a classical mechanics, right? And in this case this can be said as the quantum mechanics. This is the basic difference between the classical mechanics and quantum mechanics. Classical mechanics says you the actual position where the velocity is tends to 0, and the switched off position, that is the cannot say the actual position, we can say the region of position, that there is a range of region where can be situated the blades, right? So this is actually probability. This is the probability. Okay, so these phenomena considered under the quantum mechanics. I think you understand the basic difference between the classical mechanics and the quantum mechanics. Taken another example, suppose you have a wall. Suppose you have a wall and there is a man. Suppose you have a wall and there is a man. This can man jump up to that region. It cannot. Its energy levels, if you take this energy level of this man is that level, but this height will be higher. So if you take this as v0 and the energy is this, E is less than v naught. In classically it is not possible to go at that region. This is not possible because classically the man cannot go go through wall, right? Through wall. This is the classically. But in quantum mechanically you can say that is the, it can penetrate. The man can penetrate like that. Penetrate. Suppose this is a man, this is the wall. This man in a probabilistic like that, this can be penetrate. Will be, there is a probability. There is a probability to go through this region. There is a probability. There is a probability, some probability in quantum mechanics. This is a classical mechanics, and this is the quantum mechanics. In quantum mechanics, this man can be penetrate to this wall, but in classical mechanics, this man cannot be penetrate to this wall. This is the basic difference between classical mechanics and quantum mechanics. I think you understand the basic thing of quantum mechanics. And you can say there is two things happening here. When the moment, when the velocity tends to zero, this become classical mechanics. When velocity is large, this becomes the towards the quantum mechanics. When velocity becomes too large, this become quantum mechanics. When the velocity becomes lower, this become the classical mechanics. This is the basic fundamental two things happening here, right? So this actually described these two things actually described in the just take the growing of light, just taken as example of light. Just at before, at the first things, the at the first time, Newton's take the corpuscular theorem, right? In the corpuscular theorem, they say he says that is the light as a, like just as a corpuscular like that, and these corpusculars can be collide with the wall and it can reflect it. So this explain the reflection law. Reflection law can be explained by corpuscular theorem. And there is, if you take these two medium, you can say that is like that velocity, and this can be changed like that. So this also explain the refraction law also explained by this Newton's corpuscular theorem. But it cannot explain like interference, diffraction, diffraction, polarization. This cannot explain polarization. This phenomena explained by Heisenberg answer sorry wave theory of Young's, I forget the name. Okay, this explained by wave theory. Okay, this explained by wave theory. So this actually particle theory, corpuscular theory, this was explained by wave theory. And this wave theory also explain reflection and refraction. So this is a standard theory which can explain all the phenomena of light, but it cannot explain the photoelectric effect. So this photoelectric effect is explained. Photoelectric effect is explained the particle theory. Particle theory of light. So in this experiment, that is photoelectric effect was explained by the particle theory. So this actually wave theory and this is the particle theory. Clear? So light has a dual nature. So you can say that is the dual nature, particle nature and the wave nature. So this is dual nature is not in light. This is for all body, all body. This dual nature have all body. That's mean all body have two nature, that is wave nature as well as particle nature. Okay. So so wave particle duality. So duality. So any body have two nature, that is wave nature and particle nature, depending upon the velocity, velocity or momentum, velocity, or accurately you can say that is momentum, linear momentum. Okay, linear momentum. How? This explained by de-Broglie. This explained by de-Broglie. How? He says that is wavelength associated with the wave of any particle is equal to h by p. H by p. Just think. This is the wavelength associated with the wave of any body. Okay. So any body have wave and the wavelength is lambda, and p is the linear momentum of any body. That is the wave theory. This says wave theory and this says particle theory, right? Particle theory. So wave theory and particle theory are correlated by this relation de-Broglie hypothesis. Okay, just consider our example, that is when a body, so this relation can be h by mv. So case 1, when v tends to 0, what you say? V tends to 0, lambda tends to infinity. So lambda tends to infinity, very large lambda. Then you consider this portion, you can say this is change is negligible. So this can be neglected. The change is negligible. Change is negligible. That's why you can predict the actual position of particle. So you can predict actual position of particle. This is nothing the classical mechanics. Clear? But when the velocity tends to infinity, very large, lambda tends to 0. Lambda 0 means lambda is very small. Lambda very small means this is like that. You can see this is like that. So if you take this portion like that, so you can see here there is a fractional change. Change is very much. Change is prominent. So change is prominent. So you cannot say the actual position. Can say probability, and this is the nothing but probability. So this is the nothing but quantum mechanics. So I think you understand about the classical basic difference between classical mechanics and quantum mechanics. Classical mechanics mean you can say the about the actual position or the accurate position where the velocity tends to 0 and the wavelength tends to infinity in terms of de-Broglie hypothesis, or in classical quantum mechanics the velocity tends to infinity and wavelength tends to 0. You cannot say the actual position, you can say the about the probability of any position. So if understand about the basic difference between classical mechanics and quantum mechanics. Okay, Now know about the starting of quantum mechanics, where the origination is h, Planck constant. Okay, so Planck constant is the origination of quantum mechanics. How? So that's why you need to know about the black body radiation. Black body radiation. For that you need to know about the black body radiation. What is the black body radiation? You know, this any black body. Black body means it can absorb and eject the light maximum. Okay. 100% black body means is absorb the 100% light or eject at 100% light. This is the black body. For black body, like that, it can absorb the light. All things thing. For black body, this average energy radiated like that, uh, h nu by kt minus 1. This was the derived from the expression by light. Okay, and there is two theories actually available. First one is the Rayleigh-Jeans theory, which says that frequency versus energy is like that. Okay, that is the Rayleigh-Jean. Okay, this says but Wien's theory says about this result will be like that. Wien's theory result like that. This is the Wien's theory of radiation. But the experimental result sorry but the experimental result will be like that. Experimental result will be like that. I think clear about the superposition of these two things. This is the experimental result. Experimental result. Okay, this is the experimental result. So Rayleigh-Jean says about this one, Wien's radiation will be say about this one, and this experimental result actually gives this data. So experimental result not matches in the Wien's or Rayleigh's, but it matches in the lower nu this matches Rayleigh's, and the upper nu this matches Wien's. Okay, so this experimental result actually explained by Planck. This Planck's say about this law, Planck's law, which says Planck's law says that is the energy density at nu, and this is nu and temperature T will be like that. Actually we did not want to derive here, this actually derived in radiation. Exponential h nu by kt minus 1. So this is said by Planck's law, and this matches with the experimental result. This matches with experimental result. Okay, this experimental result gives you this law actually gives you the Rayleigh's and Wien's case 1. If you consider if you consider that is nu is low, that is in this region. If nu is low, you can say h nu by kt minus 1 is nothing but 1 plus h nu by kt minus 1, that is h nu by kt. So you can see this is the proportional to nu. So this is the proportional to nu. So this is proportional to nu. This portion actually says proportional to nu. So this satisfy the Rayleigh-Jeans experiment. Okay. In case 2, when nu is large at that region, when nu is large, you can say this h nu by kt minus 1 is nearly to exponential h nu by kt. Okay. So this is in the lower portion. This is when you will take in upper portion, you nu t is proportional to exponential minus h nu by kt, which says the Wien's law. Wien's law. I think clear. From black body radiation, you will be get these two laws in previously, and experimental result does not match in these two law, but Planck's which gives this law, where this is the these two law actually valid in these two region, and experimental data actually explained by this experiment, by this relation. Okay. And this h and the energy here actually taken as a quantized. This is the basic starting point of quantum mechanics, is the black body radiation of uh, uh, Planck's. Okay. And if you want to find out the energy, total energy ut, this is nothing but the integration of that, integration of in the overall region 0 to infinity. So if you put this value h by h by cq, that is h by hq by cq, nu q by this, so nu q by exponential h nu by kt minus 1 d nu 0 to infinity. Okay. Now if you just take in this h nu by kt as a x, so you will be get d nu equals to kt by d nu equals to kt by h dx. Okay. And the limit will be 0 to infinity. So 8 by h by cq 0 to infinity, nu q, nu q, nu q, nu means kt by h whole cube xs cube e to the power x minus 1, d nu is kt by h dx. So you can see one h will be cancelled out, will be get 8 4 kt to the power 4 cq hq 0 to infinity x cube by e to the power x minus 1 dx. And the integrating value of this one is nothing but pi to the power 4 by 15. So you will get 8 pi k to the power 4 t to the power 4 by cq hq. This is pi to the power 4 by 15. The integral value of this will be like that. So you will be get this one 8 pi to the power 5 k to the power 4 cq hq, sorry, cq hq and t to the power 4. So this will be taken as sigma t to the power 4. This is the Stefan-Boltzmann law. Stefan-Boltzmann law. Okay. So you can say that is the energy radiation is proportional to t to the power 4. That is U is proportional to t to the power 4. Black body radiation. Black body radiation. Okay. Radiation. Okay. So here the question is the Planck's radiation nature. Nature of this Planck's radiation. Here the question arises, this is nature of the Planck's radiation. Planck's radiation. This is the question arise at that time, and this was solved by this. First things is photoelectric effect. First was photoelectric effect, which was, sorry, effect at 1905 at the during the Bengal division. This time photoelectric effect says that the photon as a wave package targeting on metal, and it eject, that is the photon particle, and it eject electron. Here this photon taken as the quanta. Quanta, that is the particle theory. Particle theory. Okay, that is the quanta. Those energy is h nu, and this actually taken in the Planck's radiation also, in the h nu Planck's radiation also this will be taken as. So this is the starting of quantum mechanics. Starting of quantum mechanics. The starting of quantum mechanics. Quantum mechanics. Okay, and next experiment was the Compton sorry, Compton effect. You know, when there's there's a static electron, this is static electron, and the wave is incident on that h nu, its wave nature will be changed h nu prime, and the electron ejected from like this. This is the Compton scattering. And number 3 is the de-Broglie hypothesis, which already explained. De-Broglie hypothesis. Okay, hypothesis. So in the upcoming lecture, we will be discuss about photoelectric effect and the Compton effect and so on. Today I want to finish at that point. In the next class, we will be discuss the photoelectric effect. So I think clear. If there is any doubt, you must comment in the comment box. Okay, this is all about me, and this is my contact detail. You can connect with me. So with the Telegram channel, this is my online platform, and this is my YouTube channel details. Go to this channel, you will get different physics related video and some mathematics. Like this session, if you learn something from this session, share this video to your friends. Either he or she also get benefit from this video. Subscribe this channel. This, if you new in this channel, those already subscribed, thanks for subscription. Press the bell icon to get notification of upcoming video. So take care. We'll meet in the next video as soon as possible. Thank you.